Okay, it's 8:05, so let's get started. Hi, everybody. Welcome to this week's meeting. So this week's going to be all about literature review and just top of the mind things. Yeah, record the meeting. I'm recording the meeting today after forgetting to record last time. But if you have not already, please join the Google group and the Outlook group, just as a reminder again. The presentations today are going to be literature review. So today I'm not presenting. It's all about you guys presenting the slides and the literature review that you have done. And then the next meeting, this is actually wrong. I'm saying the next meeting is going to be about other venues and clay, but let me actually correct this. The next meeting is actually going to be a very fun meeting because we're going to be doing a panel discussion with the people that actually attended Clay in Madrid, like the students that went to Clay, and they basically were able to attend the conference and being part of it. We're gonna do a little panel discussion with them. So the schedule on the website is gonna change. Right now, the schedule is not updated, so I'll update the schedule like tonight or tomorrow, and then I'll share the updated schedule in the on Slack, basically on a post. But basically, you guys don't have any deliverables for next week. I'm gonna go talk more about that later. But it's gonna be like this cool panel discussion about the students' experience going to Clay and attending and presenting and just being part of the group so you guys can check if that's something you'd like to do in the spring semester. And okay, so let's dive right in. So today we're going to be doing a literature review presentation. So those five students, they agreed to present today. It doesn't have to be in this particular order, so let me just go ahead and jump to the first presenter. So I think it's going to be Balaji. Balaji, are you in the meeting right now?
Oh, yes, I am. Am I audible?
Yes, yes, you are.
Oh,
Are
perfect.
you ready to present?
Oh, yeah, sure.
Cool. So I believe I mentioned 5 minutes, right? 1 minute per slide. So
Yeah,
I'll actually, cool. So just to make sure that everybody has time, I'll put a timer here. Actually, I need to share my screen again. So just a second. Let me stop sharing and then share again. And then I need to share with sound. And it's gonna be this one. And then share. Just to make sure that other people have time to present as well. This is something that we've done in the past and it works quite well. So yeah, please go ahead.
yeah, sure. Good afternoon. Good evening, guys. It's different time zone here, so I'll go ahead. So the paper that I took was Quantum Clef. It was conducted for the first time last year, so I thought it would be a bit of a challenge. I'm actually new to quantum computing, so did do some quantum physics, but not much into quantum computing, so I thought I'd go deep into that topic. So here, the objective of this paper was to develop new quantum clustering algorithms for information retrieval and recommender systems, evaluate them, gather resources for future data researchers, and allow participants to use an actual quantum computer, which was provided by D-Wave, and raise awareness of the potential of quantum clustering and form a new research community around this field. So, uh, can I go to the next slide, please? Oh, thank you. So, so this is the basic setup, and this setup does quantum annealing, which uses quantum fluctuations like quantum tunneling to find optimal solutions for optimization problems, which simulated annealing relies on classical thermal fluctuations to escape um, the local optima. And this is being done through D-Wave's network, and that is provided through their Amazon, like AWS to our local machine, pretty much, like API access. And next slide, please. So the task that we were given was to focus on formulating this clustering quantum clustering problem and using quantum annealer and simulated annealer and also a hybrid model, which is what which is what the teams focus more towards. And then the second task was to focus on the formulation of this clustering problem in such a way that can be solved by the quantum annealer. And the image over here is an example, which which is uh, a simulation from one of those like through quantum clustering, which involves finding the mass of exoplanets, uh, which is just available uh, like through NASA's open source data. And next slide, please. Yeah, so the results here are, I've got a lot here. So the results, it was basically 7 teams working on this. Here you have it was a NP-hard problem where this task focused on formulating this and the feature selection is a wide problem for this, especially for the information retrieval and also for like the recommender system, which requires the identification of a subset of the available features, like most informative, least noisy, and to train the learning model. This problem is very impacting since many of the information retrieval systems involve optimization of learning models and reducing the dimensionality of the input data, which can improve the performance. And this was what most of the teams focused on. Yeah, next slide, please. So what did I learn from this, from the paper was that due to high dimensionality in this, it's a brand new problem and you get to use quantum computers, like access quantum computers, which not most people have access to. So it's in itself a challenge. And due to high dimensionality of the data set, they decided to first apply a traditional approach to reduce the number of points, n, and to represent some points, and then perform quantum clustering through both through quantum annealing and simulated annealing, and also use the hybrid approach. And from that, I found that feature engineering is also key. Yeah, that's it. That's pretty much it. Thank you.
Cool, awesome. Thank you very much for sharing. Were you able to listen to the timer thing?
Oh yeah, I think I was quite
No, no,
spot
no,
on.
no. I'm just asking for just so I get the feedback if people are able to listen or not.
Yeah, I was. Yeah,
Okay, cool, awesome. Yeah, no, thank you very much for sharing. I actually think
yes.
you went ahead and you skipped this week's deliverable and you did for the next meeting, which was
Oh
about
yeah, because this paper had 2 tasks, which is pretty much for, like 2 papers. It was worth 2 papers. That's what I felt.
yeah, okay,
Yeah,
that's fair. Yeah, it does have like those two tasks.
yeah,
But yeah, thank you very much for sharing. The
yes.
Quantum Clay team at DIGT actually did pretty good. I think they ended up winning
Oh, cool.
the task. So, and we are going to be participating next year again. So, yeah, definitely
Yeah, hoping
interesting
for
if
that.
you like to, yeah, if you like to join the team.
Yeah,
So, very
yeah.
cool.
Thank you so much.
Thank you. Okay, next, before we do have some time today for like questions. So, does anybody has any questions for Balaji and his presentation? Okay, so if no one has a question, I do have a question.
Yeah, sure.
Why are you particularly interested in this task? I mean, you said that you have some experience with quantum work before, but
Well, like,
what
not
yeah.
exactly. I've used, like quantum physics in school, and then I mean,
Okay.
my background is in electronics. I mean, it might
Mm-hmm.
like in electronics and computer science. So we do learn quantum physics in electronics, right? So that we have a background for that, and but not actually used any quantum computers. Like in my past university at the University of Edinburgh, we had access to like uh like like quantum computer through like Rigetti's computing, like a quantum computing company. So but I've never really like had access. I felt like it was beyond my scope. I thought I'll just stick to the regular ones, but yeah, just had a look and it was interesting. Yeah.
Okay. No, that's fair. I think a lot of the folks then ended up doing quantum clay, the task. They
Yeah.
also either come from a physics background. I think Chloe did a bachelor's in physics or something like that. And
Cool.
then Lakshmi was also like just super interested in physics. And yeah, that's cool that you have the same interests as they do. So
Yeah, sure.
cool. Thank you very much for sharing.
Yeah, cheers.
Cool, awesome. Next presentation, I think is Ian.
Yeah, I just did a very basic kind of review of one literature, which was on it was talking about using kind of like uh I guess presence and non-presence data for kind of training models and things like that. So like if I think that was like data that was like in the actual area that they were training on, and then also data that was kind of like external to it to train. And I think this was on like some of the GeoClef types of um, papers and things like that they were doing. Um, so I just did a very basic. Um, and I think the idea basically was they were trying to do more. Basically, they were trying to say that by using kind of external environmental data, um, it helped to also increase the training of the traditional model itself. Um, And yeah, it was basically by using kind of external data, it helped to train the model a little bit better than just by using the main data itself on the clef. And um yeah, that's it. It was just very basic. That's all I did pretty much, yeah.
Okay.
Yeah, and I think a few kind of questions in it were just Um, so this was kind of like reviewing, it was basically just a paper that was reviewing stuff for like plant clef and things like that to say, how can we improve the training or the non-training for it. Um, and I think some of the questions would be like, does using older data help? Does using some of the kind of external data help with finding rare plants? And just what how many examples you want to like what sample size you want to use overall. I kind of might have done this wrong. I think I was supposed to actually do it on a clef main clef task or something. I can't remember. But yeah, I just reviewed one of the papers on the sheet area.
Okay. Yeah, no problem at all. Do you want to expand anything further on the GeoLife Clay task or something that you found interesting about that?
I think GeoLife is that plant clay and fungi clay and all of those things is basically Geo, right? Is that
No, no, GeoLife is its own task. So it is about identifying plants, but from satellite images, where plant clay is actually the quadrat images from like up close identifying species. So GeoLife clay is about like satellite imaging, which Anthony is super on top of that because he works for a company that puts basically maps the Earth.
a planet or
Um,
something? Oh yeah, yeah.
yeah, so he's done, or we didn't do GeoLife Clay this year, but he did it last year. And yeah, it's about satellite imagery and things like that. But it's its own task. It's not part of Blank Clay. It's part of Life Clay as a lab, but it's a different task.
So it's like the satellite one. Okay, super cool. Yeah, I was just read up on it. I read the paper a little bit, and it was basically trying to say some of the environmental, adding some certain types of data would help improve the training, the results, I guess. And but yeah, it was
Hmm.
interesting anyways. Yeah, thank you.
Okay, cool, awesome. Thank you very much for sharing. Okay, next one is humor classification by fine-tuning. Daniel Rosas.
Hi. Hi. Yeah, so my case, I decided on a clay that wasn't mentioned on the last presentation. This one is related to humor. Uh, it's particularly interesting because humor is like quite common, quite global, and still is, in case of natural language processing, is very hard to classify. For last year task and on 2023, there were 4 different tasks. 3 of them were related with translation, specifically between English and French, for jokes and humor related paragraph. Um, in the case of the papers that I review, they are focused on task 2. This one is on multi-class sentence classification. So basically, they receive a data set that contains, as it says, 1,742 training entries, and they are classified between irony, sarcasm, exaggeration, so on and so forth. What the what they need to do is use this training data to create a model that can predict the kind of humor that they will see on the test. Okay, can we move to the next one? For one of the papers, its name is on the first slide. They use a well, they tried different large language models and they trained them using um, classification. They did a prompt engineering. I wanted to show on the table, there is kind of example of what they did. So they made a prompt asking the model to classify, and then they give it the input and the response. Then once they train it using all of the data, they use the same prompt, but they leave the response open in order to train it. They use a very standard train test split, the 80-90 for the tuning, and they mentioned that they use for the for the model a GPU by themselves to reduce. Wait, give me 1 second. I wrote down this. Um, so what they say they did on that case is that it's presentation. Okay. Um, okay. Um, okay. Here they use a for the Llama 3AV language model. Since the model is very large, they needed to make it fit on a single GPU. So to do that, they use the following thing. They did compress the model weight from the usual 1632 bits down to 4 bits during training. That way they dramatically reduce the GPU memory required and still keep the performance for close precision. I wanted to keep that because they highlighted on it. They mentioned that when they submitted their different models, they made some mistakes. And even though they were getting very good results on their tests, officially they got like an 18.6. That's on the Roberta. The best one that they got was Llama 3.8B. No, for a self-test, they got almost 90%. The officially was 69.76, probably because of the overfitting. The best one for that task got 71% accuracy. Can we move to the next one? On a similar approach, or for a different paper, the what they did is train a BERT-based classifier and fine-tune it on a label training dataset. They divide the dataset that they have on further datasets to test it. So not just keeping sarcasm or irony, but further dividing it. However, they also found confusion between irony, sarcasm, and exaggeration. They also mentioned the same on the other paper, that on those categories it's really hard to make the difference. And they suggest for further classification on different papers, on further models, to make classifications on humor and non-humor, because sometimes the sentences have more than one label attached to them, and then the model struggles to make that difference between the sentences. Can we move to the next one? Now, well, in terms of things that can be used on some other task in the future, um, I think that adding more context is useful, especially in humor. Sometimes it requires mentioning data about the context and the situations in which the pun is made. Also, I think it's useful the alpaca style instructions that they use for prompt engineering. Basically, they keep the input, the the context, and then the response that they were expecting. And even when you use prompt engineering with large language models, it's necessary to make a difference between them and fine tune, because sometimes they will use on top of whatever you train, the model, the large language model will prefer whatever was pre-trained with. That's
Okay.
it.
Okay.
Yeah.
Awesome. Cool. Thank you. I do have some comments on that. So if you liked the Joker task, the team that participated from the SGT actually ended up winning
Oh,
Joker
really?
this year. Yeah, yeah. So we ended up winning. They even gave us like a little, I think it was for Joker, or was it for a different lab? I don't remember exactly, but I remember Anthony shared in the like with me a little like plaque that they gave. But yeah, so they did quite well. Rusty is the one that was leading the task for Joker, and I love Rusty. He's such a pleasure to work with. He's super capable. And yeah, so they did quite well. Even though the organizers took forever to actually release the data set this year,
Oh,
they
okay.
did like super, super well. And then the other comment that I have is that, and this is just a comment in general for everybody here at the meeting, if you are interested about like LLMs and fine tuning, we're gonna have a very hands-on, basically exercise. Is it exercise? It's basically a deliverable, but it's gonna be a very hands-on mini project for you guys in the second half of the semester that
Okay.
is going to be on pace, and it's going to be about you guys are going to be fine-tuning your own LLM or SLM, like a small language model, because we cannot fine-tune like a 400 billion parameter one, but we can fine-tune like a smaller one, like basically Llama 3.1 AB using QLoRa for low rank adaptation. And then, yeah, like you mentioned, the reduction from 32 bits to 4 bits, this is called quantization. So maybe we're gonna teach you guys how to do some of those techniques too. But if you are interested about fine tuning and LLMs, there's definitely gonna be like an exercise, a very hands-on exercise. There's gonna be three main ones. There's gonna be one about LLMs, one about embeddings, and the other one about information retrieval. So more information on that later. But yeah, so thank you very much for covering Joker. Really appreciate it.
Thank you.
Right. Oh, just to clarify, Mario, it was Touche that we got the
Okay,
certificate
touche.
in.
Right.
Yeah.
Because we ended up winning what? It was Q Clay, Quantum Clay, Touche, and Joker. And yeah, I think it was Touche that Anthony received the little gift, right?
Right, that's right. Yeah.
Okay. And then Board Clay won the best working note paper too, but that's a separate thing. Okay, awesome. Okay, next up, Rohan.
Hi, can you hear me?
Yes, sir.
Okay, so I'm Rohan, and yeah, this is my literature review. So, the first one that I did was from Quantum Clay as well. So The task here was basically to detect persuasion techniques in text, basically. So like appeal to fear or other things like that. This matters because manipulative language is a big driver of misinformation. So automatically detecting it can help fact checkers prioritize which claims to check and also support media literacy. Um, the unique angle with this one is the quantum part, obviously, which is like there's traditional NLP, which struggles with ambiguity. So this paper basically just testing out the probability models inspired by quantum theory. So yeah, next slide. So the methodology and results. Sorry, my thing is a little, yeah. I copied it from PPTX, like I made it there first, so I got a little messed up. But the data the team used was a persuasion data set, which is multilingual and annotated with different persuasion techniques. They tried two main approaches. First, the standard approach, fine-tuning transformer models like BERT and Roberta, along with ensemble methods in class balancing. Second, the quantum-inspired approach, representing text in Hilbert spaces, which come from quantum theory and modeling ambiguity, using quantum probability instead of classical probability. So they also tested like hybrid setups that combine transformers with quantum-inspired layer. The results were measured using something called macro F1 score, which is fair to both common and rare classes. The transformers gave a solid baseline, but they struggle with the rare techniques. So overall, this exploratory work, but it suggests quantum methods could be valuable for multilingual persuasion detection. So then the other slide I picked was from the NEAR IPS, I think. Yeah, in the fact-checking domain. So here the task was to decide which claims and texts are worth sending to fact checkers, what we call check worthiness estimation. The reason this matters is manual fact checking is very slow and journalists are overwhelmed by volume of claims, especially on social media. So an AI filter that prioritizes check-worthy claims reduces that overload and helps fight misinformation more efficiently. So methodology and results here. For the data, the researchers used English language tweets and political debate transcripts, annotated as check-worthy or not. Their approach was built on pre-trained language models like Roberta and DBERTA, but with an extra twist. They used constructive learning framework, which means the model is trained to pull together similar claims, the check-worthy ones, and push apart the different claims like check-worthy versus not. This encourages the model to make better distinctions, especially for subtle claims. Again, the evaluation metric was also the macro F1 score. So the contrastive approach outperformed classical baselines by a wide margin. Next slide, please. So applying these both to the new clay task, when we compare these two papers, we see strengths. The Clay 2024 paper works with quantum-inspired models, which is strong at handling multilinguality and ambiguity, especially for rare persuasion categories. And then the NEAR IPS papers, learning is strong at sharpening semantic separation between like small, very subtle claims. So if we combine them in a Clay task like check that, we could build a hybrid system, which would use both contrastive learning to rank and prioritize persuasion or check-worthy claims too. Step 2 would use the quantum-inspired classifier to refine the detection. So the outcome would be a stronger semantic clarity and better cross-lingual lingualness. And in other words, both approaches together could really boost performance in future Clay labs.
Cool, awesome. Thank you very much. I really appreciate it. So it seemed that you are very interested in fact checking,
Yeah, I
right?
know. I
Like
like picked both of them so I could find
a
kind of like
common ground. Yeah.
uh I didn't know that whoever performed first, I think he did the same one as me. The same.
For the quantum task,
Yeah,
but
I was
yeah,
sorry about that.
Quantum Clay, I think he has like two main tasks. One is clustering, and the other one is feature selection,
Yeah, yeah.
if I'm not mistaken, right?
Yeah.
I didn't know it was for fact checking stuff, like the purpose of it, but it makes sense.
Yeah.
So that's quite cool. So if you were going to pick a lab, would you pick Quantum Clay to participate, or would you focus more in like another more NLP heavy lab? Like, because there's also like fact checking at other
No,
labs,
yeah,
I'm
yeah, yeah.
assuming.
No, for sure. I mean, the reason that I picked these was to learn more about quantum clay. I don't know if I would pick it yet, but the reason I picked
Right,
these
right.
articles right now was just to learn more about it. I'm not sure yet. I think I'm still leaning more towards the NLP side, but
Mm-hmm.
I mean, it's possible, right? If I did.
Yeah,
So,
for sure.
I was just learning more about it by picking these two articles.
Okay. And why, just being curious, why are you so interested about fact checking?
Uh,
Is
more,
there a reason? It doesn't have to have a reason, but
I mean, I wasn't really more of like a reason in fact checking. I just thought that was more, I just found like that was more applicable to like day-to-day life, especially when you're doing assignments.
mm-hmm.
I'm in college, so I'm
Right.
I just feel like I like do assignments like a lot and like AI and then like checking your facts when you like do your assignments and stuff. So
Yep.
I
I
don't know,
also
it just
think
related to
that
me a little bit. So that's it.
I also think that it's good. It would be a good project to have on your resume when you're applying for jobs,
Yeah, exactly.
because especially if you want to go into the realm of like a machine learning engineer, something like that,
Yeah.
it's I think it's really good because every single company have some kind of fact checking, at least like big tech.
Yeah,
So
exactly. So
I think it's
yeah, it's just a little relatable. So that's why I decided to pick it for both of them.
gotcha.
Thank
Cool,
you.
very cool. So yeah, I think you're gonna enjoy a lot the LLM and the embedding and the information retrieval kind of projects that we're gonna have this semester,
Yeah,
and hopefully
excited.
participating in the spring too.
Yeah, yeah, I am. I am.
Cool, awesome. Thank you very much. So I think that's it for presentations, but I think we had one more person. So I think it was David Eziga, but I'm not sure if he's here. Is David here in the meeting? Okay, I don't think he's here, so I don't think he would be presenting. So, okay, let's switch focus. So, like I said, next week we're actually going to be switching focus a little bit for a meeting. The schedule looks wrong, and I'm going to be updating the schedule. So, the schedule actually says that let me get the dates here. So, it says that on October 20th, we were supposed to have a Madrid experience report, something like that. We're actually pushing that. We're like switching things up. We're gonna be doing that next week because those are the students that ended up going to Madrid. So as you can see, I believe there's 10 students. Oh man, David got cropped here. I'm sorry, David. Um, but those are the students that I ended up going to Madrid and presenting the research there. And I think they had a really good time. I think Jason is here in the call, and Jason ended up going as well. So what we're gonna do is next week we're gonna have a panel discussion with some of those students that actually ended up going to Madrid to Clay, that attended the conference, and it's gonna be a very much like laid back kind of conversation back and forth. I'll be basically asking questions to them, and we're just gonna be chatting about their experience going to the conference as representing Georgia Tech, and yeah, just being a part of it and how the experience was for them. So there's no deliverables for next week, and this is why it's saying here October 13th, which it sounds like so much far ahead, because maybe I can bring up the DSGT, actually the notes website, they schedule here, I have it here. Oop, schedule. don't have it? Just a second. Schedule. Oh, switch to tab. Hang on. Notes. Okay. So let me make this bigger for you guys. Okay, so we are here. 22nd. So this is not gonna be here anymore. We're gonna be pushing that to the 13th, like the next literature review they're gonna be doing. There's gonna be a fall break on October 6th. So we're not gonna be meeting on October 6th. And then next meeting is going to be the panel discussion. So I'll be updating this. So this is gonna be a panel discussion on September 29th. On October 6th, we're not going to be meeting. It's going to be a little fall break, just so you guys have some time. And then on October 13th is going to be the next literature review, which I'm going to be talking about what we're going to be doing. And I'm also going to be reminding you guys in the next meeting. So I didn't have to make those slides. I'm just making right now so you guys kind of know what's going on. And then the research proposal is going to be on the 20th. And that's gonna actually be something that is gonna be due for you guys. So it's like initial research proposal draft for a possible CS A901 or a CS A903. So yeah, I'll be talking more about that probably in the future meetings, but just to give you guys a summary of what that's going to be is that we're going to be offering a CSA 903 in the spring semester for people that want to do the research and they want to get credit for it. So most people, the CS A901 are going to be mostly for alumni, so they have access to PACE. And the A903 is going to be for the students, for like everybody else. And it's a 3 credit course, so plan accordingly. I'm going to be talking about that I think a lot of students, they underestimate the amount of work that it goes into a research project like this. It's quite a lot. And yeah, I'll get your question, Rohan. And yeah, so basically next week we're just gonna do the panel discussion, then we're gonna have a fall break, then we're gonna do a literature review, and then on the 20th we're gonna have this research proposal draft due, and I will share more information about what's the research proposal and how to do it. But we do have um a competition, apply methods, resources. We do have a research proposal. Where is it? Choosing a venue over new other research writing a paper conducted. Research proposal. So we actually have an example of a research proposal. This is the one that Anthony did it back in 2024 for GeoLifeClay. And it's literally like his research proposal that he did like in a Google Doc, and basically he got a professor to supervise his research. But basically the main goal, or one of the main goals of the interest group, is for everybody to finish the interest group with a research proposal that you can then use for a 903. So this is like basically the last deliverable, this final research proposal drafts, which is going to be like basically in September or December. That's the main goal for the interest group. So right now, after the fall break, we're gonna have the draft that is gonna be due, but it's only gonna be due on October 20th. So it's still a month away, and we have time. I'll definitely be talking more about that and what to do, what to expect. I'll be sharing the one that I've made it, so you guys have something to base your ideas on. And this is why the literature review is so important, because basically when you're doing a research proposal, you're basically doing about the task that you want to solve, right? So it's very specific to what you want to do. So yeah, I'll be talking more about that later, but I just wanted to like give kind of an overview. So we're not no deliverables for next meeting because the panel. The one after that on October 6th is going to be a break, so no meeting. So for October 13th, this is going to be the deliverable, and I'll be sharing that again at the end of next meeting, just to say it again, I guess. But it's going to be basically this other literature review, but this one is going to be all about Clay. And basically what I'm asking you guys to do is to do an overview of a Clay task. So people have actually done that today. I believe the first presenter today did presented the overview about Clay. So basically, what is this? Like, what's a literature review of an overview of a task? So what I want you guys to do is you're gonna go on a specific task in the working notes page of Clay. And the 2025 proceedings webpage has not been published yet. So do it on the 2024, which is totally okay, because it's gonna get you acquaintance, it's gonna get you like basically understand the task that you're doing. So one thing, you're gonna choose a task, you're gonna go on the working notes page, which I'm gonna show you where to find the overview paper. And then that's gonna be like the first slide, basically just talking about the task that you chose, what the task is about. The second slide is going to be on the common approaches and methodologies for solving the task. And for this slide, I would like you guys to go through a few or a couple papers that were submitted for solving that particular task and trying to see common themes about it. Like, oh, Jason said the 2025 papers are published. Really? Hang on, let me check that. Because I checked that today and I couldn't find it in the proceedings, at least here on the website. So it says Access Labs working notes available soon. Not sure, Jason. Oh, dang. Oh, okay, this one. But I was talking about specifically about like the Seor WS proceedings thing here for the working note stuff, which I'm not sure if I guess I can log in via the institution and then see everything, but it's just nicer to have on the website. But anyway, so yeah, so slide 2 is going to be common approaches. So once you identify the task that you want to talk about, go through a few papers and read through their methodologies and try to pick what they have done, like the models that they have used, the techniques that they have used to solve that challenge, and try to see common patterns about that. And then the third slide is going to be basically a quick brainstorm about either research questions or alternative approaches that you think would be helpful for solving that particular task. So okay, so let me go through. I know that we have like 10 minutes left, so let me go through each one of those. So again, this is not due next week. It's not due the week after. It's only due in October 13th. And I'm gonna be talking again about this for the next meeting. But and the reason why I'm talking so much about this is because doing this literature review here is gonna help you write the research proposal document. That it's basically, if you want to do a 903, you need that document for doing the 903. So I'm trying to basically put everybody in a successful position. So you guys like really understand the task that you want to do and the common approaches that are done for solving that task. So when you draft that research proposal, you understand very clear, like you have a clear understanding what's the work that needs to be done for solving that. So the first thing that you're gonna do is you're gonna go on this website here. And this is the Clay 2024 Working Notes website. And it's basically the website where every single working note paper has been published. And the website is ordered in alphabetical order by the lab name. So for example, here we have BioAsk, and then if I scroll down, we have another lab, check that. And then if I keep scrolling down, we have Eloquent, eRisk. I mean, you get the gist. Like you have the labs and then every single paper within that particular lab. So for example, let me go to LiveClay since it's the one that I'm most familiar with. So for example, LiveClay has 5 different tasks. And usually the very first papers on this page, it says overview of BoardClay 2024. So if I click here, it's basically a paper that the organizers of the task put together, just giving an overview of the competition and what the competition is. So if you ask me, hey, what's the best way to find about like what are the tasks available and the competitions available and things like that, it's going on this website, the working notes page, and just browsing through the tasks and the within the labs that you're interested about. And then, oh, I don't know like what the lab is about. Then just go to the conference page. So for example, if I go to Clay 2024, because I mean, I'm looking the working notes at the Clay 24 to 2024. And if I go on, let me see, publication, no, labs, you have like every single lab here and what they're basically about. And then you can click, for example, Live Clay, and you have like the tasks that they're about. So board clay, fungi clay, geolife clay, plant clay, snake clay. That was for 2024, and then the organizers and things like that. But the main thing here to note is that you have the working notes website is divided by labs, and then each lab has an overview paper. And then, for example, I'm very interested about board clay, and then I can simply find other papers here that were done by board clay. So for example, fine grain, blah, 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 patchwise. How about the one? Oh, this one. This one's really good, which is by Mario. And I think Mario has been placing like crazy high on board clay since ever. I think he's working at a museum now. I met him at the conference last year. He's a really nice guy. But anyway, so yeah, so this is the paper by Mario, and basically it's his methodology and his solution about how he solved the board clay. And I definitely want to read this because if I'm trying to solve board clay for next year, I definitely want to know what the really high ranked person did for solving that challenge. And you can see like everything here. So like another one about, oh, this is the one that we did it. So you can check it out and just check like the paper that we have done it for the task. But you can also check like the papers that people have done for all the other different tasks. And then you can see what they have done differently. Okay, let me pause here for a second. I know the Rohan, you had a question.
Yeah, I was just wondering, the class that you said, I'm assuming that's a graduate class only.
Yeah, that's a great question. I need to check that if we can do something about the undergraduate. I know that Anthony said it that for the undergrads, it's a completely different class. But the process is pretty much the same. You just need to kind of have a research proposal, but you need to find a faculty to supervise you. But because you are on campus and you do have access to professors, if you kind of have a good relationship with one professor, and it has to be a professor on the College of Computing. So if you have a good relationship with them and you have this research proposal, you can go up to them and you can ask them to basically be your advisor for this class, and then you apply. I can one thing that I'm gonna try to do, especially this semester, since we have more undergrads, is kind of try to be more informed about what you guys can do to pursue that kind of A903. I think it's like a 5903 or something like that.
Yeah,
I think Anthony knows the exact number, but I'll check that out and then I'll let you guys know like your options. But yeah, the A903 is for the graduate level kind of class.
Okay,
Um,
thank you.
yeah, no problem. So yeah, so with that, that's kind of the meeting for today. I know that we still have 5 meetings, so 5 minutes on the meeting. So if anybody has any questions that is related to anything that I said about those like last 10 minutes or 15 minutes about the future of the group and the presentations and the labs and things like that, I think we can keep recording and just have those 5 minutes to be in the recorded session. And then I'll be here again after 9 p.m. I'll be here for like any further questions that you guys may have that is not related to this. So if anybody has any questions that is related to what I said, yeah, just please feel free to shoot them out. Anybody has questions? Okay, cool. So with that, I'm going to stop the recording here, and I will stay if anybody has like any other questions that is not related to that. But thank you very much, guys. Thank you for showing up again for another week. So no deliverables for next week. Next week is gonna be the panel session. The week after is the break, and then the week after we're doing the literature review that I covered here. And I'll be talking again about that in the next meeting. Okay?
Sorry, it looks
Cool.
like two people had two people had the same question in the chat. So for online students, how can we reach out to professors to sponsor us for the proposal?
So we're going to be doing that. I already got you guys covered. So we are going to be offering our own A903, and I'll probably be the TA. And Nick Lido, he's the director of research at OMSCS. He's going to be the advisor. So basically what we're trying to do is that I've done an A903 and I know how hard it is to try to find faculty to supervise your research. So we're just taking care of that for you. And the goal of having this research proposal document is to make as easy as possible for you guys to do a 903. So Nick Lido is going to be the one that is going to be basically giving you a grade at the end of the semester. I'll probably be one of the TAs if we have more. It depends how many people are going to be doing the 903. And then, yeah, basically we're trying to make as easy as possible for online students to do independent research and trying to provide a structured approach of doing that.
Thank
So
you.
hopefully that answers your questions.
I have one more. So is there a chance that this could lead to being able to pursue a project-based master's with OMSCS? Or would we require some more semesters?
Yeah, so the project base is completely unrelated to this. Like if you want to do it, there's nothing stopping you. You can simply do it. I don't even think it's something maybe you have to apply for it. I'm not quite sure, but yeah, you can be part of it. I'm sure that it's like a viable option.
Okay, thank you.
Okay, cool. Let me stop the recording now, and then I can take more questions. Okay, but if you guys don't have any more questions, then feel free to drop. And thank you very much for coming to this week meeting.